Hello, everyone. Welcome to the class of EPLAN and Electrical Control Technology. We have learned the basic knowledge and software operation of EPLAN, and we also know that one of the main functions of EPLAN is to draw electrical schematic diagrams. However, when we get the drawings made with EPLAN, we may not be able to read them, just like the drawing we see now. There is a pile of dense labels in the page navigator, which I believe many of you cannot understand. In fact, these labels composed of symbols, letters, and numbers reflect a powerful function of EPLAN, that is, project management. Next, I will show you the project management function of EPLAN. As we all know, EPLAN is a project management software based on the database. All operations are managed based on projects. What is the specific operation process? First, create a new engineering project. When creating the project, fill in the project name, project save location, project template, project creation time, and creator in the dialog box in turn. Generally, China's standard GB or International Standard IEC is selected for the project template. The next step is structured management of the project. Many electrical engineers are unclear about the meaning of project structure in EPLAN and the meaning and purpose of higher level code, $, and location code, +. It is difficult or impossible to understand others' drawings accurately when they are full of marks like equals EB1 plus ET3 minus KM1. Why should project structure be set? The answer is very simple. It's for the convenience of project management and drawing viewing. EPLAN generally manages projects at 3 levels. For the functional plane structure, the corresponding EPLAN higher level code is represented by the equal sign. The corresponding EPLAN location code for the location plane structure is represented by the +. The corresponding EPLAN device identification for the product plane structure is represented by the -. The device identifier represents the component name, so the components are named according to the project level. This part of the content is relatively abstract. To better understand the project structure of EPLAN, let's look at a simple example. Let's take the personal organization structure of a company as an analogy to EPLAN's project structure. We know that there are large and small companies. Small companies have only 7 or 8 employees. Medium ones have about 100 employees, and large companies have thousands of employees. Similarly, the core of an electrical project is the electrical schematic diagram. So the number of schematic diagrams can reflect the size of the project. For projects of different scales, their schematic diagrams vary from a few pages to dozens of or thousands of pages. For different sizes of companies, let's envision the following scenarios. Scenario 1. The project structure is numbered sequentially. When a company has only several or dozens of employees, due to the small number and unclear division of labor, the company can set up a manager, and the rest of the people are employees, 1, 2, 3. It is equivalent to that a project has only several or dozens of pages of schematic diagrams. Because there are not many drawings, circuits with multiple functions are often put on the same page. So in a project, we have drawings 1, 2, 3. This is usually used for some mechanical processing equipment, such as industrial washing equipment, general processing machine tools, and printing machinery. If there are not many drawings, it means that the number of components in the project is not large. At this time, there is no need for project structure because the components can easily be found. Therefore, we can use the sequential numbering structure, which has the advantages of being simple and clear. Scenario 2. The project structure is represented by the location code with the plus sign. When a company has hundreds of employees, it's too much work for the manager to directly manage them all on his or her own. It's also less efficient. At this time, it is necessary to set up hierarchical departments for management. That way, if we want to find one person among hundreds of people, we can first find his or her department and then find the person, which will save more time. Similarly, if a project has hundreds of pages of schematic diagrams, it will be difficult to find a certain equipment component in the drawings still numbered sequentially. In this case, the location code is generally used to divide the drawings of hundreds of pages according to the installation positions, which are usually inside control cabinets. At this time, the components in the projects have names and positions. Just like a company where everyone has his or her own department, we can easily distinguish Zhang San in the R&D department from Zhang San in the production department because the department they belong to, that is, location code, is different. This project structure is usually used for some small and medium-sized automation systems, assembly lines, sewage treatment systems, etc. Scenario 3. The higher level code equal sign and location code plus sign are used for the project structure. Bigger companies have hundreds or thousands of employees working on different products, and some departments even have the same names. At this time, it is far from enough to only set up departments for management. It is also necessary to group these departments into different branches and offices. This is like a schematic diagram containing hundreds or even thousands of pages in a project. To easily find a component in these drawings, we need to divide the project according to different process sections and installation positions. If the process section is represented by the equal sign as a higher level code, and the control cabinet is represented by the plus sign as a location code, the component can be found by judging which process section and control cabinet it belongs to. This kind of project structure is mostly used in metallurgical industry, heat treatment, highly automated automobile assembly lines, etc. After understanding the meaning of higher-level code and location code in the project structure, we can easily understand the last equipment identification, that is, the corresponding component name in the electrical drawing. In other words, the whole project structure is to facilitate us to view the specific position of an electrical component in the drawing. Now we can go back to the code of equal EB1 plus ET3 minus KM1 in the drawing mentioned before. It is not difficult to find that it tells us that the contactor, KM1, is installed in the control cabinet 3 of section 1. Isn't it convenient for project management and even more for drawing viewing? In fact, in teaching and training, there is often only one section and one electrical cabinet, so the component name can be simplified into the form of minus device identifier without the higher level code and location code. We can even remove the minus sign in the front and further simplify the name into device identifier. For example, the circuit breaker component can be directly named as minus QF1 or QF1. Isn't that much simpler? Of course, if you want to accurately name the electrical components in the software, Please master the symbol names of commonly used electrical components. Everyone, I just led you to learn the project-based management of EPLAN. After learning this lesson, you need to understand two questions. First, why should the project be structured in EPLAN? It is to facilitate project management and drawing viewing. Second, how should the project be structured? I'll leave this question to you to think about after class. That's all for this lesson. See you next time.